Hi smart learners, today we'll be discussing acid base and salts. We shall begin with acid. What is an acid? An acid is a substance, according to Arrhenius, which dissolve in water to produce hydrogen ion as the only positive ion. This each ion represents an acid. So example, we have hydrochloric acid giving hydrogen ion and chloride ion. We have trioxynitrate 5 acid giving hydrogen ion and trioxynitrate 5 ion. When you look at this equation, what is common to them all? It is the hydrogen ion. Now, the modern definition of acid says that an acid is a substance which dissolves in water to produce hydroxonium ion or oxonium ion or hydronium ion as the only positive ion. So this is called oxonium, or you call it hydroxonium, or you call it hydronium what? Ion. Now we look at classification of acid. There are two classes of acids: organic acid and inorganic, also called mineral acid. So we look at organic acids and the sources. Why do we call them organic? Because they are gotten from plants or animals. Example, we talk about ascorbic acid, rightly gotten from vitamin C. We talk about lactic acid, gotten from milk. Then we also talk about amino acid, gotten from protein, fatty acid, gotten from fat and oil, oleic acid, gotten from palm fruits, and so on. Inorganic acid are also called mineral acid. Why? Because they are synthesized or prepared in the laboratory. So we'll look at examples of inorganic acid. Inorganic acid, constituents, and molecular formula. Molecular formula. So the first inorganic acid we talk about is trioxynitrate 5 acid. Trioxynitrate 5 acid. What are the constituents? Hydrogen, oxygen, and nitrogen. And what is the formula? HNO3. Then we talk about hydrochloric acid. What are the constituents? Hydrogen, chlorine, and the formula is HCl, and so on. Now we go to we go to types of acid. Types of acid. Now we look at, we have what is called strong acids. What are strong acids? Acids can be classified into two types based on their strength. We have what is known as the strong acids. These are acids that ionize completely in water or in aqueous solution to produce considerable number of ions. Now, what are examples? Now, for strong acids, they can be divided into two. We have what is known as oxo acids. What are oxo acids? Oxo acids are acids that incorporate or embodies an oxygen atom in their molecule. Examples are tetraoxynitrate 5 acid, tetraoxoacetic acid, tetraoxophosphate 5 acid. All these are examples of what? Oxo acids. Now, what are examples of strong oxo acids? A very simple formula to know this is number of O atoms greater than number H atoms by 2 or more. Number of O atoms greater than number of H atoms by 2 or more. Students will prefer to cram examples of strong acid, but you don't need to cram this. All you need to do is understand that strong acid can be divided into two. Oxo acid, that is acid that incorporates oxygen atoms in the molecule. And a very simple way to know strong acid, strong oxo acid, is this formula. Number of O atoms greater than number of hydrogen atoms by 2 or more. Example, look at H2SO4. Here we have 4 O atoms. We have 2 hydrogen atoms. The difference between them is 2. Therefore, that qualifies this as a strong acid. Then you talk about HNO3. What do we have here? 2. Here, in tetraoxynitrate 5 acid, we have 3 oxygen atoms. So, and 1 hydrogen atoms. When this is subtracted from this, we have the difference between these is what? Is 2. Therefore, that qualifies tetraoxynitrate 5 acid as a strong oxo acid. Recall I stated that to identify a strong oxo acid, the number of oxygen atoms must be greater than number of hydrogen atoms by 2 or more. That is the difference. Just as you can see, 4 oxygen atoms, 2 hydrogen atoms, the difference is 2. Then tetraoxophosphate 5 acid, you see the number of oxygen atoms here is 4 and the number of hydrogen atoms here is 3. The difference here is 1. That means that this is not a strong oxo acid. Now the second class of strong acid are called the hydrogen halide acid. Hydrogen halide acid. What are hydrogen halide acid? These are acids that embody a halogen atom in their molecule. Example is HCl, HBr, and so on. So for hydrogen halide acids, strong hydrogen halide acid include hydrochloric acid less than hydrochloric acid less than hydrogen iodide acid. You might be wondering, why is HF not the strongest hydrogen halide acid? The reason is because fluorine, having a smaller atomic size, will strongly bond to the hydrogen atom, and that will render hydrogen fluoride acid incapable of releasing hydrogen ion in aqueous solution. Why is hydrogen iodide the strongest hydrogen halide acid, despite the fact that iodine is the weakest electronegative halogen? It is because iodine has a very big atomic size, therefore a less affinity for hydrogen ion. Therefore, if hydrogen iodide is dropped into water or introduced into water, it can readily relinquish or forfeit the hydrogen ion. Therefore, that qualifies it as the strongest hydrogen halide acid. And now, we proceed to physical properties, laboratory preparation of acid. We look at weak acid. So for weak acids, what are weak acids? These are acids that ionize partially or incompletely in water to produce fewer ions. Examples, just as discussed previously, they are divided into 2. So we have weak oxo acids. Weak oxo acids. So how do we identify weak oxo acid? Difference between number O and number H atoms less than or equal to 1. Less than or equal to 1. Difference between number O and number H atoms less than or equal to what? Equal to 1. Example, we have here to be H2CO3, trioxocarbonate 4 acid, trivial name carbonic acid. The number of hydrogen atom is 3. The number of hydrogen atom is 2. The difference is 1. In that event, carbonic acid or trioxocarbonate 4 acid is a weak oxo acid. Then H3PO4, tetraoxophosphate 5 acid. Now, when you look at this, in tetraoxophosphate 5 acid, the number of oxygen atom is 4 and the number of hydrogen atom is 3. The difference here is 1. That means tetraoxophosphate 5 acid or phosphoric acid is weak oxo acid. The next one is hypochlorous acid or oxochlorate 1 acid. The number of oxygen atom is 1 and the number of hydrogen atom is 1. The difference here is 0. Recall that the rule says the difference between them less than or equal to 1. Now, that's for weak acid. So, we proceed to laboratory preparation of acid. We proceed to laboratory preparation of acid. Laboratory preparation of acid. So the first is dissolution of acid anhydride in water. Now, what is acid anhydride? As the name suggests, they are oxide of non-metal or non-metallic oxide that dissolves in water to produce acids. In other words, they are non-metallic oxide which dissolves in water to furnish or produce aqueous solution whose pH is less than 7. In that event, we have here to be carbon 4 oxide dissolves in water to give you, as you can see, H2. Add this oxygen to this, that will give you CO3, trioxocarbonate 4 acid. Then sulfur 4 oxide dissolves in water to give you H2SO3, sulfurous acid or trioxosulfate 5 acid. Now, on the other hand, there is a term known as mixed anhydride. Why do we call it mixed anhydride? Because they give mixture of 2 different acids, often a weak and a strong oxo acids. Example is nitrogen 4 oxide. It will dissolve in water, as you can see, to give you HNO2 and HNO. So when you look at this example, it is evident that this is dioxonitrate 3 acid or nitrous acid, and this is trioxonitrate 5 acid or nitric acid. And recall from our classification of acid that the difference between this and this is 2 oxygen, 1 hydrogen. The difference is 1. 2 minus 1, 1. That qualifies dioxonitrate 3 acid as a weak acid. The difference between these 3 oxygen and 1 hydrogen, the difference is 2. That qualifies nitric acid or trioxonitrate 5 acid as a strong acid. So we call nitrogen 4 oxide a mixed anhydride because it dissolves in water to give mixture of acid, mixture of oxo acids. Now, the second method of preparation of acid is by direct combination of constituent elements, by direct combination of constituent elements in presence of what? Catalyst. In presence of catalyst. Here, hydrogen gas combines directly with chlorine gas in the presence of activated charcoal, to give hydrogen chloride gas, which dissolves in water to give you hydrochloric acid. So another example is hydrogen gas and bromine vapor to give you hydrogen bromide, which dissolves in water, hydrogen bromide gas, which dissolves in water to give hydrobromic acid. Now, the third method of preparation of acid, in the laboratory is by displacement of a weak or more volatile acid from their solution by a stronger or less volatile acid. For example, we have this to be sodium trioxynitrate 5 solution, and we have combining or reacting with tetraoxosulfuric acid. So let's say the product. Tetraoxosulfuric acid is a more stronger acid, a stronger or less volatile acid. And why this is a what? A more volatile acid. So what happens here is tetraoxosulfuric acid will displace trioxynitrate 5 as trioxynitrate 5 acid. Balance the equation, and then we have here to be sodium tetraoxosulfate 6. So in that case, we have this as sodium tetraoxide 6. Then another equation is potassium carbonate, potassium trioxocarbonate 4 reacting with sulfur tetraoxosulfate 6 acid. This is a less volatile acid, less volatile or stronger acid. Why this is weaker acid. So this will give me trioxocarbonate 4 acid and potassium sulfate. So to ensure that the equation is balanced, potassium 2, carbon 1, oxygen is 3 plus 4, 7, 3 plus 4, that's 7, hydrogen is 2, hydrogen is 2. So you can see here that a stronger acid or a less volatile acid, in this case tetraoxosulfuric acid, displaced trioxocarbonate 4 acid from a solution of its salt. Now, so then we move with the next. We discussed the physical properties of acid. Number one, the presence of acid in an unripe fruit accounts for its characteristic sour taste. Number two, a solution of acid has pH less than 7. Number three, an acid will turn moist blue litmus paper red, and phenolphthalein solution colorless. And also the concentrated form of strong acids such as hydrochloric acid, trioxynitrate 5 acid, tetraoxosulfuric 6 acid, and tetraoxochlorate 7 acid are potentially corrosive. Next, we discuss the chemical properties of acid. So the first here is action of metals. Strongly electropositive metals like sodium, potassium, magnesium combine with acids with the effervescence due to evolution of hydrogen gas. Example, sodium combined with hydrochloric acid to give you sodium chloride, aqueous solution, with an effervescence due to hydrogen gas. Sodium 2, balance the equation so as to conform to the law of mass conservation, or law of indestructibility of matter, or law of conservation of energy. So sodium 2 atoms of sodium balanced, hydrogen 2, hydrogen 2, chlorine 2, chlorine 2. And next is magnesium combined with tetraoctosulfate 6 acid to give magnesium tetraoctosulfate 6 aqueous and hydrogen gas. So we balance the equation: magnesium 1, magnesium 1, hydrogen 2, hydrogen 2, sulfur 1, sulfur 1, oxygen 4, oxygen 4. Now, note that the action of metals with trioxynitrate 5 acid does not liberate hydrogen gas. This is because trioxynitrate 5 acid, being a potential powerful oxidizing agent, will arrest the liberated hydrogen and oxidize it to water, while itself is reduced to nitrogen 4 oxide or nitrogen 2 as the case may be. For example, copper with trioxynitrate 5 acid, as you can see, do not be tempted. We give you copper with trioxynitrate 5 acid. We give you copper 2 trioxynitrate 5, water, and nitrogen 4 oxide. So you can see that the reaction of trioxynitrate 5 acid with metal will not liberate hydrogen gas, because the hydrogen gas that will be liberated will be arrested and oxidized to water. What does that demonstrate? It demonstrates the singular fact that trioxynitrate 5 acid is exceptionally an oxidizing agent, but simultaneously it is reduced from 5 oxidation state of +5, remember trioxynitrate 5 acid, to +4 nitrogen 4 oxide. So we balance the equation: copper 1, we'll place a 2 here. So hydrogen 2, hydrogen 2, nitrogen 2, nitrogen here is 2, plus 1 here, that is what? 3. So nitrogen is unbalanced. I'll put a 2 here, making 4, and then I'll place a 4 here. So nitrogen here is 4, nitrogen here is 2, nitrogen here is 2, that's 4, balanced. Then hydrogen here is 4, hydrogen here is what? 2. I'll place a 2 here. So that balances hydrogen. So hydrogen here is 4, hydrogen here is 4, that is balanced. Nitrogen here is 4, nitrogen here is 2, plus the 2 here. This is 2 times the 1 here, that makes it 4. Oxygen here is 12, 2 times 3 is 6, 6 plus 2, that is 8, plus 2 times 2, 4, 8 plus 4, that gives it 12. Then the second chemical properties of acid, number 2 properties of acid, is action with alkaline. Action with alkaline, and this is called neutralization reaction. This is called neutralization reaction. That is the combination of hydrogen ion from an acid with hydroxide ion from an alkaline to form water. In other words, we can say neutralization reaction is defined as the reaction of acids with alkaline to form salt and water. But essentially, the basic product is water. So as you can see here, we have hydrochloric acid react with sodium hydroxide. These combine with this, and these combine with this. So this will give you sodium chloride and what? And water. Then the third reaction of acid. The third reaction of acid is action with triazole carbonate for salt. So acid will react with triazole carbonate for salt to give you water and carbon dioxide. So a typical example of this reaction is hydrochloric acid plus sodium triazole carbonate 4. So this will give you sodium chloride, water, and carbon dioxide. That is, this goes with this, and then this goes with this. So remember that two oxygen is leaving. One oxygen is leaving to give you water. So you have here 2B. So in that case, we balance it by putting 2 here. We balance it by putting 2 here. And that balances the equation. This brings us to the end of the concept of acid. The next class, we shall be discussing the chemistry of base and salt.